Another day, another story. The feasibility of colonizing Mars is explored in detail. The video examines the challenges and opportunities presented by the red planet's environment, including its thinner atmosphere, lack of liquid water, and extreme temperatures. Welcome to Tabo Eminent Channel. Why Mars? The search for a backup planet, Earth's vulnerability to asteroid impacts and climate change. The allure of the unknown, uncovering Mars's secrets and the potential for life. The dream of expanding humanity, a new frontier for exploration and colonization. Mars's harsh reality, challenges we must overcome: thin atmosphere, lack of protection from solar radiation and extreme temperature swings. Lack of liquid water, the need to find or create water sources for survival. Extreme temperatures, coping with freezing cold nights and scorching hot days. Technological solutions, conquering the Martian landscape. Habitat development, designing self-sustaining environments with artificial gravity and air recycling. Resource extraction, utilizing Martian resources for fuel, water, and construction materials. Terraforming, the long-term goal of modifying Mars's atmosphere to make it more habitable. Human adaptation, preparing for life on Mars. Physical and psychological adaptations, the effects of low gravity, radiation exposure, and isolation. Diet and nutrition, cultivating food in harsh Martian conditions. Social dynamics, managing interpersonal relationships in a confined and challenging environment. The future of Mars, a new chapter for humanity. The potential benefits, scientific discoveries, resource exploitation, and a new home for humanity. Ethical considerations, the impact on Mars's environment and the rights of future Martian inhabitants. The ultimate question: will humanity be able to overcome the challenges and establish a sustainable presence on Mars? Could we live on Mars? A detailed look. Humanity's fascination with Mars, the red planet, has been long-standing. Recent advancements in space exploration and technology have reignited discussions about the possibility of living on Mars. Why Mars? Mars is the most Earth-like planet in our solar system, making it a prime candidate for human habitation. It has a 24.6-hour day, polar ice caps, and evidence of past water activity. Additionally, its proximity to Earth allows for relatively feasible travel compared to other planets. The challenges: atmospheric composition. Mars' atmosphere is 95% carbon dioxide with only trace amounts of oxygen. This makes breathing impossible without life support systems. Radiation exposure. Mars lacks a magnetic field and has a thin atmosphere, exposing the surface to harmful cosmic and solar radiation. Extreme temperatures. The average temperature on Mars is about -80 degrees Fahrenheit, -60 degrees Celsius, with drastic variations between day and night. Limited resources. Water is present primarily as ice, and there are no readily accessible food sources. Any sustainable colony would need to rely on advanced technology for resource extraction and production. Isolation and mental health. The psychological toll of living millions of miles away from Earth in a confined environment is a significant concern. Communication delays further exacerbate this challenge. Air on Mars. Humans need oxygen to survive. And the Earth provides plenty in our atmosphere. So, one of the biggest challenges of putting people on the planet is the shortage of oxygen. The air on Mars is thinner than that on Earth. On Earth, 21% of the air is oxygen, which is what makes it the ideal place for human life. But on Mars, oxygen makes up 0.13% of the air. The majority is carbon dioxide, which is harmful to humans. NASA has been experimenting with MOXIE, an instrument that would convert CO2 to oxygen on Mars. So far, this instrument on the Mars Perseverance rover has managed to successfully create oxygen from CO2. Other challenges of living on Mars. Aside from the necessities to sustain life, there are other challenges that people would face if they were to live on Mars. For example, the temperature gets very, very cold at night, below -100 degrees Fahrenheit. Mars also has dust storms, high levels of radiation, and less gravity than Earth. So, before we can start to call the red planet home, we'll need to solve these problems. Food on Mars. Growing food on Mars won't look like the farms that we have on Earth. Instead, crops would need to be grown without soil, such as tank farming or aquaculture. This is where the food would be planted in nutrient-rich water and fed with artificial lights. Some scientists have discussed creating a more suitable atmosphere for growing food on Mars. That would involve adding some greenhouse gases into the Martian atmosphere to make it thicker. However, due to the enormity of that project, it's more realistic to think that humans living on Mars would rely on aquaculture. Water on Mars. Scientists have found water on Mars, but not in the same form it's found on Earth. There is some water on the surface and below, but because of the extreme cold on Mars, it is all ice. And not the ice as we experience on Earth. On Earth, ice is just water, but on Mars, with high levels of CO2, ice contains water ice mixed with CO2 ice. There is also water inside of rocks, but the lack of surface water would be a challenge for humans wanting to settle on Mars. Scientists continue to learn more about Mars, which will help them find out where we can obtain water from. Shelter on Mars. Building places to live on Mars poses a challenge. Transporting construction materials to Mars could end up being way too expensive. So, scientists propose the possibility of using materials from Mars to construct homes. Potential solutions: life support systems, advanced systems for oxygen generation, such as electrolysis of water and artificial photosynthesis, are under development. Technologies like SpaceX's proposed habitats aim to provide sealed environments with breathable air. Radiation protection habitats could be built underground or shielded with regolith, Martian soil, to reduce radiation exposure. Additionally, protective suits and advanced materials could be employed during surface activities. Terraforming and temperature regulation. Long-term strategies involve introducing greenhouse gases to thicken the atmosphere, raising temperatures. Short-term solutions include heated habitats and insulating materials. Sustainable resources techniques such as hydroponics and 3D printing could allow colonies to grow food and manufacture tools on site. Ice mining and water extraction technologies are crucial for survival. Addressing psychological challenges. Virtual reality, social interaction simulations, and regular communication with Earth could mitigate mental health issues. Rotating crews and leisure activities might help maintain morale. Current progress. Space agencies like NASA and private companies such as SpaceX are actively working on Mars exploration. Missions like Perseverance have provided invaluable data about the planet's conditions. Plans for manned missions in the 2030s signify a step closer to potential colonization. Ethical and environmental considerations. Colonizing Mars raises ethical questions about our responsibility toward an alien environment. Introducing Earth life could irreversibly alter Mars' ecosystem, if one exists. Conclusion: living on Mars is a daunting yet exciting prospect. While technological advancements make it seem increasingly plausible, numerous challenges remain. The journey to becoming a multiplanetary species will require not only scientific innovation but also careful consideration of the ethical and psychological dimensions. Nonetheless, the dream of Mars continues to inspire humanity to push the boundaries of what is possible. Thanks for watching. Request you to subscribe the channel.